Hello, you are watching the study guide for the Unit 2 test. A numerical expression is a mathematical sentence that contains numbers and operations. For example, 5 minus 25 times 4. An equation is something we are a lot more familiar with. It shows that expressions on either side are equivalent to each other or equal to each other. This can be something like 5 plus 2 equals 7. Order of operations is referring to the set of rules for evaluating expressions. This is where we get the acronym PEMDAS, P-E-M-D-A-S. PEMDAS is a way to remember parentheses, exponents, multiplication, division, addition, or subtraction, or the order of operations. Parentheses are the first thing that you need to evaluate in an expression, if it has any. We don't need to worry about exponents, but just so you know, there are those little numbers that are sometimes accompanied by other numbers, maybe even letters, such as the example. Multiplication. When you get to multiplication and division, you have to remember that you evaluate from left to right. Take a look at this example. It says 10 divided by 2 times 4. Some people get tricked and they see multiplication and division as stating that you should multiply first. But what you should see is what is happening first in my expression. 10 divided by 2 is happening first, and then I multiply. So I will divide first. 10 divided by 2 is 5. I like to write it right underneath so that my work is organized. And then I bring down the rest of the expression. So times 4. And now I evaluate. 5 times 4 is 20. This is my answer. Let's take a look at the next problem. I see we have subtraction and addition. Again, just because in our acronym addition comes first does not mean it has to come first in my problem. I have to go from left to right. Looking at this from left to right, I see I have to subtract first. 20 minus 4 is 16. I write it right underneath, and then I bring down the rest of my expression. 16 plus 7 is 23. So now we're going to practice evaluating some expressions. At the top of the page, I wrote PEMDAS to remind myself of the order of operations. If I forget these letters, I can tell myself, please excuse my dear Aunt Sally. Maybe you want to create your own mnemonic to remember PEMDAS. Go ahead, but make sure that you have it in the right order. Okay, so let's start evaluating. I see several operations. I see division, multiplication, addition, and I see these parentheses. I know I have to do whatever's inside the parentheses first. So I have to add 38 plus 39. Oh no, a mistake. This actually should be a plus sign. After I add 38 plus 39, I get 77. I write 77 right underneath it, and I write the rest of my expression. I ask myself again, what do I need to do first, the addition or the division? Well, in the order of operations, I have to divide first. So I'm going to look at this part of the expression. 44 divided by 11 is 4, and then I just rewrite the rest of my expression. Then 77 plus 4 is 11. So my answer is... Alright, I have to admit, I don't know what I was thinking, but we are not doing that problem. On to the next one. Number 3. Although we can figure out 13 times 11, I think it would have been better if I did 12, since that's a fast fact that we know. So let's change that to 3, and then let's evaluate. I know I need to start with my parentheses because that is the order of operations, and I have 33. Then I write everything else down. You might do it a different way. Maybe your parents taught you a different way to organize your work, and that's perfectly fine to do so in that manner. Then I need to do addition first because it appears first when I'm reading it from left to right. So 33 plus 24 is 57 minus 16. And my answer is 41. Again, I start with my parentheses first. 14 minus 3 is 11. And I rewrite everything. And I ask myself again, what comes first, multiplication or subtraction? Well, it's multiplication. 5 times 11 is 55. And 55 minus 9, I'm gonna work my problem out over here. My answer is 46. The directions state select the equations that are false. I wonder why that's underlined. Probably because it's trying to draw your attention to it. Usually we're asked what is true, but here they're asking us which ones are false. So I have some equations. I do see the equal sign, and I know that on both sides, they have to be equal or equivalent to each other. So if one side equals 14, the other side has to equal 14. I still have to follow the order of operations, so just in case, I'm going to write it at the top so I can refer to it. Starting with the left-hand side, I see I have division or addition. Well, I know division comes first. So 24 divided by 3 is 8. I bring down everything else, so I already did this, so plus 14. 8 plus 14 is 22. So on my left-hand side, it equals 22, so the right-hand side must equal 22 for it to be true. But remember, I'm looking for the ones that are false. 2 times 11. And in fact, these are true. They are equal to each other or equivalent to one another. So I am not going to select this one. Okay, let's say I was going to put a check mark in the box. This is not one that is false. It is true. Okay, 8 times 5 is 40. And let's see what's on this side. I see we have more than one operation, addition and multiplication. I know I have to do multiplication first. 5 times 6. Then I bring the rest down and I ask myself again, this one only has one operation, but I would ask myself again, what do I need to do first? 10 plus 30 is 40. These are equal to each other, so it is not one that I am selecting. This is true. In the next problem, I have 21 minus 18 times 3. I know I have to do whatever is inside the parentheses first. So 21 minus 18. I get 3 times 3. and 3 times 3 is 9. On the other side, I have 96 divided by 12. So I need to ask myself, what times 12 equals 96? And the answer is 8. These do not equal to one another. They are not true, they are false, or it is not equivalent. So this one actually I am selecting because it is false. I see I have multiplication and subtraction, and I know that I do multiplication before I do addition or subtraction. 7 times 6, and then I take away 30. If one side equals 12, then the other side must also equal 12 for it to be true. I have addition and division. So I'm going to start with the division because that comes before addition or subtraction. 27 divided by 3. I have to ask myself, what times 3 equals 27? 9 times 3 is 27, and then I have to write the rest and solve. 9 plus 9 is 18, and 12 and 18 are not the same. They are not equivalent. So therefore, this is false. They are not equal to one another. And I will be selecting it because they want me to select which questions are false or which equations are false. Here, I'm looking for the equations that are true. Let's start with A. And I find my equal sign. I know one side has to be the same as the other side, or both sides have to be equal to each other. Again, we are doing order of operations when evaluating or solving an equation or evaluating an expression. And I have a parenthesis here, 8 plus 4. Then I bring down the rest. 12 times 2 equals 24. On the other side, I also have parentheses and I have 4 times 2. 8, and then we bring the rest down. 8 plus 8 is 16. These are not true. This is false. So I won't be selecting that. Looking at B, there's my equal sign. I have parentheses, 5 times 3, 15. I bring the rest down. 16 minus 15 is 1. I barely have space for it. I'm sure you also barely have space for it. So I go to the other side. 2 times 4 is 8. And then I bring the rest down. 8 divided by 8 is also 1. So this is true. They are equivalent. So I will select B. You can pause the video now and solve C, D, and E. And then I will show the answers in just a moment. So pause the video. Which expression represents the words, the product of 7 and the difference of 6 and 4? I have some key words here. Product, difference. I know product is the answer to a multiplication problem. And I know that difference usually is related to subtraction. So my only two options that have multiplication and subtraction are A and C. But the statement says the product of 7 and something else. So that means I'm going to have 7 times something else. Also, it says the difference of 6 and 4. So that means that somewhere in there, I have to find 6 minus 4. And I can't do that here because according to order of operations, I would actually have to do 7 times 6 first. And if I do that, I can't do 6 minus 4. So my answer is C, 7 times 6 minus 4. So just having the correct operations is not enough information for you to decide that it is the correct answer. We have to look back and think to ourselves, does this make sense? If I do this with order of operations, will I still get what the sentence is telling me? Which words represent the expression? 12 plus 3 divided by 4 minus 1. 12 plus 3 divided by 4 minus 1. They didn't really indicate using any words like then or first or multiply by, divide by. They didn't really indicate any sort of order, so I wrote it out exactly how I read it, and it does not come out to the same thing. So it can't be A. The difference of 12 and 3, the difference, no, that's not the difference. It would be the sum because the difference is related to subtraction. So it's already wrong. I'm already crossing it out. I don't want to think about it anymore. C, divide the sum of 12 and 3, okay, by the difference of 4 and 1. This sounds right to me. Let me try to just plug in some numbers and read it again. So let's say this is 15 and this is 3. It says divide, then I would read it, divide 15 by 3. That still makes sense to me because I read 15 divided by 3. So far, that looks correct. Let's look at D. Divide the difference of 4 minus 1 by the sum of 12 and 3. They have a lot of similar words, but they flip the order. Let me see. Let's plug those numbers in so I could just read it a different way and see if this makes sense. So this is 3. And this is 15. So it was a divide 3 by 15. Can I divide 3 by 15? Or ask myself, how many times does 15 go into 3? For now, the answer is no, I can't do that. At a bake sale, your friend sells bags of cookies with 4 cookies per bag. She has sold 24 bags and has 20 cookies left. Which equation can be used to find the number of cookies she started out with? So let's take a look at some of the information we know. There are 4 cookies per bag. She sold 24 bags and she has 20 cookies left. We want to know how many cookies she started with. So if you look over here, you know how to figure this out. She started with a certain amount of cookies. You minus whatever she sold, and you're left with some cookies, right? You started with something, you took away the ones that were sold, and in this case, you're left with 20. So, can we figure out how many cookies she sold? It says she sold 24 bags. Okay, she sold 24 bags, but that doesn't tell me how many cookies. Oh, wait. Here it says that there are 4 cookies per bag. So I know I'm going to multiply. The word per is also a clue that you're going to multiply. So I have 24 bags times 4 cookies in each bag. That's how much cookies she sold. Okay, 24 times 4. Let me bring everything down. I have the number of cookies I started with minus 24 bags, right? Times 4. That's how many cookies I sold equals 20. In this problem, I wouldn't have to use the parentheses anyway because I will multiply first. However, in this problem, they do include it first. They do include it rather, and I will still get the same results. So in the test, they're not going to ask you to figure out the equation and then also solve for whatever letter or variable that they give you. They will ask you separately. They will show you this equation and then you have to solve for the variable or solve for the letter C. So let's do that here. This one I believe is a little bit harder than the ones you have, but if you know how to do it this way, you'll be able to do it that way as well. So you already know a lot more than you think. You know that on each side of the equal sign, it has to be the same number. So we know that on this side, we have to equal 20. We just have to figure out how to get there. So let's solve what's in the parentheses first. We have 24 times 4. 24 times 4, we're going to do repeated addition. If we don't know how to solve this, we can draw. We have enough time to do whatever we need to do. You might even think about it as groups of 25, like quarters. And you add that all together and you get 100, but you have to take away 1, 2, 3, 4 because it's actually 24 to get your answer. There's many ways to solve this part, but I'm going to do repeated addition. So 4 plus 4 is 8, plus 4, 12, plus 4 more, 16. 2, 4, 6, 8, plus 1, 9. Then I bring down the C minus, and I have my 96 there. I'm getting closer. Something minus 96 equals 20. If I said C minus 2 equals 5, or what minus 2 equals 5, I'm sure you would easily answer 7. But how did you get that? How did you know that this is actually 7 minus 2 equals 5? Well, you know that because you actually added these two together. 5 plus 2 is 7. So I know that 7 minus 2 equals 5, right? They're part of the fact families. We are doing the same to solve for C here. So C, something minus 96 equals 20. I can add these two numbers to find what is my starting number. So 96 plus 20 is 116. So 116 minus 96 equals 20. And I could always actually solve that to see if that's true. Therefore, C equals 116. That's how many cookies she started with. Okay. One teacher and 23 students visit a zoo. The teacher pays 12. each student pays 9. Use the expression 12 plus 23 times 9 to find how much money they pay in all. So again, the teacher pays 12. Each of the 23 students, they pay $9. So I actually need to figure out how much the students paid altogether. So order of operations will tell me that I need to multiply first anyway, but it does just make sense to me that I need to find this out first. So I need to do 23 times 9. All right, 23 times 9. I don't know that fact just off the top of my head. So one thing all of us can do is break down the number, decompose the number. It's easy to multiply multiples of 10, so I want that friendly number that ends in a 0. 23 is made of 20 and 3. So now I'm going to rewrite my multiplication problem. I flipped it. I put 9 times 20 instead of 20 times 9, but as we know, that does not matter. You could write it either way. At the end, I'm going to add them together, right? Because 23, when I broke it apart, I know that it's 20 plus 3. So I have to add it back together. It's easy to multiply 9 times 20 now, because I know 9 times 2, which is 18, and then I just add that 0. 9 times 3 is 27. Now I add it together. I got 207, but I'm not done. That is just how much the students paid. I still have to add how much the teacher paid. So I actually have to bring this part down. 12 plus 207 is 219. That is how much they paid in all. Miss Crespo ate 4 cookies for breakfast and 8 cookies for lunch at school. Mr. Salt ate 7 fewer cookies than Miss Crespo. How many cookies, C, did Mr. Salt eat? Well, let me see. If she ate 4 at one time and 8 for lunch, I know I have to add that to figure out how much she ate in all. And then Mr. Salt, he ate 7 fewer, so I know that's subtraction. He ate 7 less. Now, this all equals how many cookies he ate. So that equals C. 8 minus 4? I don't know why we're subtracting, so no, we're not subtracting. 4 plus 8? Okay, maybe. 7 minus 8? Why are we taking... Oh, Miss ate his cookies. Okay, maybe 7. He ate 7 fewer. And then 8 plus 4. That could be it. And then we have 4 plus 7. Why? She ate 8. That's not it either. I'm looking at these two. All right. I think C works. It does have parentheses, but I know that either way, I'm going to do addition first. So I think this checks out. Seems to match. This is 12 minus 7. That equals 5. So Mr. Salt ate 5 cookies. C equals 5. Let me see the next one. 7. Those are he ate 7 fewer. So I see what you would say minus. But wait a minute. I'm saying 7. Take away 8. I can't even do that. And also, he ate 7 less than me, or 7 less than Miss Crespo. So I need to add up her numbers first. I know I need to do that first. Therefore, my answer has to be C, where I add the cookies first that I ate, or Miss Crespo ate, and then I take away however fewer Mr. Salt had. Another tip for when you see a question like this You can, and they want you to solve for the letter. So in this case, it would be S. What makes this equation true? It has to make sense. It has to equal 0 at the end. One thing I can do to double check is I can actually plug it in. So I will rewrite this and solve. I'm putting the 1 in place of the S and see if that gives me 0. I have to do the parentheses first. 7 times 1 is 7. And then 14 minus 7, well, that's 7. So this is not right. Can't be that. Next, we have the number 2. So 14 minus 7 times 2 equals 0. I gotta see if I evaluate this side, will I get a 0? Let's find out. 7 times 2 is 14. 14 minus 14 is 0. Yep, that checks out. Thank you so much for using the study guide and studying for your test. Please make sure that you also use your corrected homework, your chapter review taken from the book, any extra practice sheets, and your journal with your notes in order to study for the test. Good luck!